For this circuit we need to find, there are two unknowns, I delta and V naught. These two we need to find. Now we will apply node voltage method again, and we can see that this is the node with maximum elements, so we can call it the reference node. And then when we observe at the circuit, we can see that this node's potential is V naught, or voltage is V naught. This node's voltage is 10 volts because this is just from ground. The voltage is increased by 10 volts by this source, and this node's voltage is, this is ground, and then we have a current dependent voltage source, but that is, the polarity is in the opposite, so it becomes minus 20 I delta. So that is the potential of this. So first we should try to write the KCL or node equation for node V naught. If we do that, we can see we can label three currents going outwards like that, and one will be V naught minus 10 volts over 10, V naught minus 10 over 10, which is this current. Then the current going downwards will be just V naught over 40, and then we have V naught minus 20 I delta, so V naught minus 20 I delta over 20. So all three outgoing currents sum equals to 0. So basically we have written KCL at that for that node, and if we multiply by 40, we get 4 V naught minus 40 plus V naught plus 2 V naught plus 40 I delta equals to 0. So that becomes 7 V naught plus 40 I delta equals to 40. So notice for this problem there are two unknowns, so we basically need just two equations, and if we try to write the node equation or KCL for this node, there is a difficulty though. We can write the current equation for this branch, because we know this voltage, but we cannot write the current equation for this one because there is no resistance there, and we don't know what's the current. We just know the potential here. We know this potential, so we can't write that. We don't have that information. So let's see what we can do for this node. For this node we can write KCL again. So this is one current going downwards, and this current is given. We couldn't write current equation for this one as well, for this branch as well, had this current not been given, because it's the same as this branch, but this current is given as I delta. So what I will do, I will write 10 minus 10. So basically this is 10 minus V naught over 10, 10 minus V naught over 10, that will be the current going in that direction. And then we have, I will try to write this current, which is also, I'm trying all the outgoing currents I'm writing on the left hand side. So that will be 10 minus 20 I naught I delta divided by 30. 10 minus 20 I delta divided by 30, because the resistance is 30. And then we have I delta as entering current, so I will write like that. Now this one we again multiply by 30, so we get 30 minus 3 V naught plus 10 plus 20 I delta equals to 30 I delta. If I rearrange this circuit, it becomes 3 V naught plus 30 I delta equals to 40. That will be my equation 2. So we have two equations. This is equation 1 and that's equation 2. So what we can do, there's a mistake actually. This one will be 10 I delta, sorry, not 30, because the polarity, so basically what I have done is I have taken the minus 3 V naught on the right hand side and this one also on the right hand side, and the 40 remains, 30 plus 10 remains on the left hand side, but then I have written the right hand side as left hand side and left hand side as right hand side. So 30 I delta minus 20 I delta it will be, and it will be 10 I delta. So now what we can do, we can multiply, so we can 1 minus 2 times 4, that's what we can do. Or let's do it other way around, or maybe like that, doesn't matter. So we have 7v naught plus 40 I delta is equal to 40. 7v naught plus 40 I delta equals to 40, and then we have multiplied, so 12 I delta, 12v naught plus 40 I delta. Basically I am trying to cancel I delta, and multiplied by 4 it becomes 160. So once we subtract, this is getting cancelled, this is minus 5v naught and this is minus 120. So v naught equals to 120 over 5, which is 24 volts. And once we have v naught, we can find I naught as well. So that's 10 I delta, 10 I delta. So I'm using equation 2, 40 minus 3 v naught, 40 minus 3 v naught. So it becomes 40 minus 3 into 24. So it's becoming minus 32, 10 I delta. So I delta is becoming minus 3.2 amps. The negative sign means the current is actually downwards. So here the current will be downwards, and so on. This potential will be positive, and like that.